In this video, we shall talk about what kinds of testing really exist. It is important because all those nice activities like planning, criteria establishment and so on are impossible without knowing how can we test. We shall start with two fundamental approaches, with functional and non-functional testing. As we can see, the whole testing may be divided into these two streams. So, what functional testing does? It tests that functional requirements, exempli gratia like encrypt, compress, archive, and so on, are developed good enough. Non-functional testing tests non-functional requirements. This is usually about speed, reliability, security, usability, and so on. Of course, both parts are important. We may not rely only on functional or only on non-functional testing, as well as may not rely only on functional or only on non-functional requirements. We absolutely need both parts. That is why software testing covers them both. As usual, here are some official definitions of functional and non-functional testing and functional and non-functional requirements from ISTQB glossary. So once again, pause the video, read and remember those definitions. They are useful. There are a lot of testing activities, as you can see here. Unfortunately, there is no standardized official classification. Even this classification was produced by myself, so any other software testing specialist may come with his own approach. But this approach was not invented by myself, it was only written down based on the experience I have. If you want to see the whole picture, please visit this URL. There you can download this picture in high resolution and explore it yourself. And we are returning to this already familiar picture. And now we shall review all those ideas in details. By code execution, we may split software testing in two streams, static and dynamic. So, static testing refers to any testing without code execution. The main idea is without. So, we may test the code itself, we may test documentation, prototypes, screen drafts, some pictures, and so on. The dynamic testing involves the execution of the software. So we start some software or component or system, we run them, and we test them during their work. Speaking about access to application code and architecture, we may divide our approach into three separate ways. First of all, it's white box testing. Here we may access the internal structure of the source code of any component or a system, but we absolutely have to mention here that there are several conditions. First, we have to understand the code. We must know the programming language, frameworks, and so on. Second, we have to physically access this code. Sometimes we may not. And the third, it's legal questions. We are to have permissions to see the code. For some cases, for some reasons, such access to source code and internal structure and architecture must be illegal. So, we absolutely should take into account all these three conditions. The second is black box testing. It's performed from the point of view of the end user, so we may not reference the internal structure. We may probably do not know some programming language, we may not have physical access to some code, or for some reasons we may have no legal right to access some code, or maybe we really do not want to. We only use some software from the point of view of the end user. Gray box testing combines those two approaches. So here we may have access to some internal structure, to some source code of some module or component and so on, but we may not have that access to some other components. And that's why the third approach combines the first two. If we divide our approach by specification of testing level, we may see the next three ideas. Speaking generally, there are more than 3 levels here, but now in our brief course we only review those 3 ones, and we shall start from the bottom. Unit testing. In unit testing we test some individual part of software, some component. We test units because any complex system consists of many little units. So first of all we have to test those little units. Then we somehow integrate several units into one bigger subsystem, and integration testing comes to the stage. Here the idea is to test interaction between some modules, between some units, some components. So we combine something little into something big, and we see how it works. And finally, when the whole system is assembled from a lot of small units into bigger units, and then from those bigger units into the whole system, it's time for system testing. With system testing, we analyze the whole system as something inseparable, and we see how the system works. One more thing we should absolutely mention here. While analyzing, for instance, some defect, we are usually going in the opposite direction. We are taking the whole system and then we trying to break it into some subsystems and identifying faulty one, and then we break that subsystem into little modules to identify where the defect comes from. The next idea is simple. We may divide software testing by automation level into manual testing, everything that's performed by our hands, by our minds, usually without any help from automated systems, from computer, and the automated testing, where we hopefully trying to pass as much effort to computer as we can, in order to save our precious time to think, to plan, to create more test cases, to analyze the current situation, and so on. So, a lot of actions may be performed both manually and automated. Some actions may be performed usually only in manual way. For instance, it's usability testing and so on. And some tasks absolutely need automation. For instance, low-level operations, high load performance testing, and so on. If we are speaking about importance of functions and tests, they also come out with 3 levels. First of all, we shall start with smoke testing, and during smoke test we trying to concentrate on critical functions of some component or systems. In real life, such functions are absolutely necessary should work for end user to be able to use some application or service. For instance, imagine a mobile phone that doesn't power on, or a mobile phone that has faulty screen or microphone. With such faults, with such defects, it is impossible to use this device, and that's the illustration of these crucial ideas smoke test is concentrated on. The second level is critical path test. This test covers functionality used by most users in their everyday life. Speaking about the same example about the mobile phone, For instance, this is some scheduler, some morning alarms, some notebook, address book, and so on. A lot of users use this in their everyday life. Of course, if in some phone there are some defects with the phone book, it is possible to use this phone. It is possible to make calls or answer calls or browse the internet, but it is not good, and a lot of users will see that defect and they will be angry. The third level is extended test. Tests on that level usually cover all the functionality like nice to have. So let's continue with the same example. For instance, we have some special mobile phone and there is such requirement that a nice flower should appear at the corner of the screen on the birth date of the user. And for some reason that nice flower does not appear. And what's from that? Is it so really bad that a lot of users will throw that phone away and will ask their money back? Of course not. But if a phone does not power on, does not call, that's the tragedy. If a phone have faulty morning alarm or phone book, it's not a tragedy, but it's bad. If a phone doesn't have that nice flower or something so insignificantly like this, it's not a tragedy. But if our customer produces such requirements, asks for such functionality, we shall test that. And the last but not the least, we may divide testing approaches into positive and negative. With positive testing, we are trying to work with the system as nice as possible. We never try to make some mistakes, to bring some harm to the software. We use correct data, perform correct actions, and so on. With negative testing, we are doing the opposite. We are trying to somehow break the system. We use incorrect data, perform incorrect actions. We are trying to make the life of the software as hard as possible. But in both situations, both here and there, we always expect that our system under test, our application, our software survive both with correct data and incorrect data, both with correct actions and incorrect actions. So we never expect the software to fail. We expect it to somehow find the way to continue work perfectly. Finally, let's take a look at the big picture once again. We see that there are a lot of approaches of dividing software testing into some separate substreams. It is not really necessary to memorize all those ideas right now. The main goal here is for you to know that software testing has variety, huge variety of approaches, and we shall try to cover a lot of those approaches in our course, in our further videos.